because bandwidth issues will be there otherwise.
Okay. So should I give my presentation? Should I start my presentation?
Sir, just a minute, sir. Dear participant, now we have Dr. Vibhakar Shrimali with us. Dr. Vibhakar Shrimali, sir, graduated in Electronics and Communication Engineering from MBM Engineering College, Jodhpur, India in 1987, and he's received his master degree in Electronics and Communication Engineering from Delhi College of Engineering, Delhi. He completed his PhD from Indian Institute of Technology, Roorkee, and his research interest includes image processing with a special focus on the image applied on the medical sciences and different other applications. He has been teaching electronics for more than 30 years with emphasis with the medical electronics. He is also the member of Institute of Electronics, Electrical and Electronics Engineer, IEEE, Society of Engineering in Medicine and Biology, USA, and he is also a fellow member of Institute of Electronics and Telecommunication Engineering, India, Institute of Engineers, IE, India, and the life member of Computer Society of India. He has worked for around 2 years in NIT Delhi as an officer on a special duty when its academic activities were initiated at Delhi, and has been experienced in around 10 years of the technical teachings and administration experience when he is working as a technical education headquarter of government of NCT of Delhi on the various assignments of the additional assistant director and the deputy director. After being selected through UPSC, he is currently working as a professor and head of the department in Electronics and Communication Engineering at GP Pant Government Engineering College, Okhla, Delhi. He has published many papers and in different reputed national and international journals, and he is presently guiding 4 research scholars for the at present 4 research scholars pursuing the PhD under his supervision. We welcome you, sir, on behalf of the organizing committee. Please share your screen and start your presentation, sir.
Thank you, Dr. Abhishek. First of all, I regret that I'm joining this FDP a bit late. In fact, the scheduled time was 1:30. I was held up somewhere. His post-lunch session normally gets delayed. Morning session, you know that, yes, but once you get yourself engaged in the first half session, your chances that you may get delayed, but in spite of my best effort, I could not get into. So I hope I'll be able to cover up whatever I wanted to share with you. Today is the last day, and everyone would be very keenly waiting for the valedictory session and completing the FDP program. But I hope I'll just brush up initially what all you have discussed so far in this FDP, and then I'll give insight of what is the image processing. Let me see what best I can share with you. Is my presentation visible to everyone?
Yes, sir.
Yes. Okay. So you, the participants, would have got insight into about what all drone is there, what are the various applications. I'll be quickly brushing up what are the different drones, and then the major application I'll elaborate is related to the various image processing, maybe for mining, maybe for forest conservation, or maybe for military applications. But all these applications, apart from as a carrier for items to be passed on from one place to another, the drone has a major application in image processing. I hope some of the August speakers would have dealt of that also. I'll also be touching upon digital image processing, how that is being applied through the drone applications. So drone technology, this is what would be my focus, the different type of RPAs, categories of RPAs, why fly drone image analysis, and digital image processing. This is would be the presentation focus. So these are, as you know, RPA, the stands for remotely piloted aircraft, RPA. So these are the different type of RPAs. I hope this would have been discussed. You have the major type of drones or the RPAs are given here: fixed wing type, multi-rotor type, hybrid type. So this is how you precisely symbolize the different type of RPAs. These all you would have cover up in the various sessions. This is another orthocopter drones which resembles to the flying birds. Basically, you can see here on one side, earlier we have been using these, you would be knowing, even the pigeons were being used, even the kites, they were being used to carry the messages. They were putting it in their zoo and they have been taking those messages. Something similar applications have been looked into, and we have developed these drones also. Then how do you categorize these different drones as per the DGCA norms? So you have 5 different categories of drones. Again, I'll say that this probably Abhishek would be in a better position to let me know that yes, these different categories would have been discussed by some of the speakers who would have dealt about the different configurations about the drones. So I'll quickly brush up what all has been discussed. So the nano, which is less than 250 grams, that is what is, then you have micro, which is varying from 250 grams to 2 kg. Then you have a small from 2 kg to 25 kg. Then you have medium, which is of weight of 25 kg to 150 kg. And then large drone, which is almost like a small a copter, which is more than 150 kg. So which is used for carrying heavy payloads, and in emergencies they carry quite heavy items. So these are the different categories as per the DGCA nomenclature, nano to large. Why do we fly drone? These are the listing of the various applications where the drones are being used. Military, search and rescue operations. You would have seen these days number of places there have been landslide. People are getting trapped in between while they are commuting. So rescue operation, the drones, they play a very key role. Search and rescue. Apart from these landslides, getting trapped, or sometimes what happens is there have been flood. People have gone. I'll show you those some pictures also where they have been trapped and they have been. You would have seen in the recent news various places in India as well as even China also. I just saw some videos where there have been huge landslides and the water getting into the urban areas. People, they are getting carried away, not only men and women, but even the huge vehicles, they are flowing in the rainwater, such a heavy. So there also the drones, they play a key role. Then surveillance, as you know, on the border for the security reasons, the drones, they are giving surveillance. What is the movement? If there is any encroachment across the border. Then traffic monitoring is another application. Firefighting, digital archaeology, environmental analysis, agriculture analysis, gas mapping, coastal survey, film and media, law enforcement, telecommunication, mining, wildlife management. So you have a long list of applications where the drone have been playing a key role and have been helping for rescue operations by and large. So we'll touch upon some applications and see, maybe like law enforcement. A vehicle is moving and say, suppose you have to identify, you have to find out where the vehicle has moved. So you have to continuously monitor what is the number plate of that vehicle and where it is moving, because sometimes what happens is that even if the vehicle knows, you would have seen in some of the movies, the drone is flying on the top, or maybe the copter is flying on the top and the vehicle is moving on the road. So they are following and having the surveillance. So these type of applications, we'll see how you achieve this and what is the important role the image processing has to play at the as the backbone of all these applications. Image analysis. So here you can see drone use artificial intelligence to speech pouch, so that you can see they are entering into the unauthorized region, maybe in dark, and how you have identified there is a movement maybe across the border. The drone are able to look into. So these are the images. So now you have to identify the major image processing. The role is not only to capture these scenes or pictures from the camera, but to identify, localize what is how many number of people they have entered, whether they are carrying some ammunitions or not. So this is, you can see here. The next application is mining. Mining, they can find out stockpiling measurement, what all has been digged out, what all has been estimated reserves, estimating marble reserves. Green proved reserve, orange is probably reserve. You can see here what are the marble reserves from different. So this giving the different color, identifying the different reason of interest. Say suppose you are looking for a marble, you are looking for a granite. So you have different characteristics of the images and you have to do the analysis, find out the characteristics, find out first the reason you have to identify, then what are the characteristics of the reason. How do you get that? You get it based on the different characteristics, the parameters, maybe like texture. What is the texture? What are the textural parameters? You have a long list of textural parameters also when you are doing the image analysis. If you go into depth, you will find out. So suppose in the mining applications, the various reasons, and then identify the reason of interest, and then localizing and finding out the characteristics of that particular reason. That is what all encompasses the digital image processing. You can see here, power grid inspection, detection, underground flow lines, whether if there is any restriction or if there is any blockage on the flow line, that can also be captured. You need not to go in person. The drone can go fitted with a camera. They can have the infrared cameras. They look into night vision. They go into depth, find out, mapping the flow lines. You can map also the flow lines. You can see the right inside the pictures. Detect overheating components on an entire field of electrical systems. So suppose if anything for electrical distribution, some component is getting heated up. So if there is a heat, what will happen is that the color would be different. And color is a type of parameters when you are doing the image analysis. You can see in this picture on the left hand side, the center point is getting heated up, which has been encircled with a black ring. I'm just showing you the glimpses of different applications of image processing, which the images which have been captured or which are being captured by the drones. See, now zones of damage severity. Say suppose because of the mining or maybe deforestation, what all damage has been created. So you can have the images, the satellite images as what you get, and you find out the related to the conservation of the soil. If the soil is getting deteriorated or it is becoming of non-cultivable land, that also you can find out. And for such applications, you are widely using these drones. And next is wildlife management. You can see counting wildlife. On the right hand side, you can see the drone is flying on the top. You can count the group of the elephants which are moving. So how many elephants are there? How many baby elephants are there? So you can count and find out. So similarly, animal birds depicted by yellow colors. On the right hand side, you can see the birds. If you look closely, you can find that these all yellow colored regions, they are depicting the birds. So wildlife management, mining, power distribution, flow measurement, counting animals using infrared imagery using from drone. You can see here also again how this is being done through infrared, because say suppose it is like tiger reservoir is there, so reserve forest is there for tiger or maybe lion. In that case, you can find out how many of them you need not to go. So it becomes otherwise very difficult to identify how many animals related to that tiger reserve is there. So you can find out using drone fitted with the camera, counting animals using infrared imagery from drones. Another application is oil spilling mapping. Say suppose there is a refinery, oil refinery maybe at Gujarat or maybe at Bombay High. The ONGC is doing a lot of exploration from the underwater below the sea they are doing. So when how this oil is affecting the ocean water, because if the oil becomes excessive, then it may be harmful for the water animals and they may damage the water and the water reserves also. So this is how you can see the various colors. On the left hand side picture, you can see the various colors have been depicted, depicting the intensity or the gravity of the oil which is split or spread around in the water bodies. So you can have a rooftop survey also of the region using drone, what all arrangements have been made from security reasons or from developing a particular site. So you can have those vegetation monitoring and analysis. Vegetation, whether it is disappearing or how it is far it is spreading, dark green, healthy, red, unhealthy. You can see on the right hand side when you are monitoring vegetation, because of a lot of construction or deforestation, you get the regions which are not having any greenery, which are being depicted with red color, yellow color. What is being depicted with green depicts that yes, it is a lot of vegetation is available there still. So with these various applications, what are the challenges and constraints when you are doing the image processing or when you are taking the image? The challenges and constraints includes flat and small view of objects. Say when you are looking for a water body, or maybe when you are looking for the vegetation or deforestation or mining, you will find that small view of object. The camera, because the depending upon the drone which is being used, may have a small camera or it will not be able to cover up a larger region. Difficulty in labeling images. Another difficulty is labeling images. Which region is green, different color labeling, you have to give different. And that would be possible only when you know that yes, what is the insight of the image processing? What are the different regions? How do you demark? How do you segment them, the different regions, and then demark them? Object overlap. This is also one of the major constraints, that the different regions they overlap. Some regions, say for example, vegetation. Some regions they'll have thickly forestation is there, and some reason they are mildly having the greenery, or maybe in the rainy season you will find by and large every region some patches would only be left out where you don't find any greenery. So objects are overlapping. large image size. The area which is to be covered or to be monitored is very large. So these are the major difficulties when you are doing the image processing or maybe looking into monitoring of the different applications through drone. Say suppose what happens is, if you are looking from the satellite, if you are taking from the images from the satellite, geostationary satellite, then geostationary satellite, 3 geostationary satellites are sufficient to cover the whole of the earth, as you would be knowing. Geostationary satellite, just 3 would be covering the entire globe. But the major constraint with the drone is that they are flying at a lower height, and since they are flying at a lower height, the region which is to be monitored would be small at any particular instance. So these constraints and various applications, I hope you will agree with me that by and large, the drone is doing the image processing or the image analysis of the various applications. So let us have an insight of what is image processing, and how do you do this in while you are capturing the various images through drone. Let us understand what is images first. What is an image? An image is a visual representation of some measurable property of person, object, or phenomena. In mathematical notion, digital image is defined as a 2D function Fij, where I and j denotes spatial coordinates and F is called intensity or gray level at that particular point. You can see here the whole of the image. This is being depicted into different regions, or maybe the smallest element, which is known as pixel. Those who are having the background of image processing, or those who have studied the image processing course, they would be knowing about how do you define I and j. They define the coordinates of this smallest element, which is known as pixel, which defines the coordinate, and f, which is a function which defines the intensity or gray level at that particular point. Gray level, if it is a black and white image, you will define as a gray level, or if it is a color image, you define what is the color combination of the primary colors at that particular pixel. So this is the smallest element. So while we are processing the image, we process or we code, keeping into view that we are scanning the whole image, keeping into view that the smallest element is a pixel, and we move pixel by pixel. We'll see as we go ahead. So how do we do that? This is an analog image of a tree, and you digitize it, and this is how do you get a digital image. A 2D function IXY representing a continuous tone image. IXY is the brightness or intensity of a point at location XY. I, X and Y can take a continuous values. You can have continuous value. You can see here. In digital image, I and J are integers, and I is also an integer. I, which is depicting the intensity at a particular point, is also a digital value. So you can have specific digital value for a particular point or a pixel in the image. You can see, which is on your left hand side, you have an image which is a continuous tone image, which is an analog image. You use a digitizer or a scanner, and you transform this into a digital image. Once it has been digitized, then the smallest element of this digital image is defined as a pixel, which is identified based on the coordinates of that particular point and the intensity at that point. So intensity is defined as I, the coordinates are I, j. Wherever you feel that you have some query, you just interrupt me and then ask if you have any query in this regard, because these are the basic fundamentals of image processing. Those who have not done a course on image processing, maybe for them it is a new thing and they can interrupt. Those who have done a course, for them it would be just a review, a quick review. You can see here, once it has been digitized, you sample them. The continuous tone image IX is scanned and its brightness is measured or sampled at discrete locations to form an element in a rectangular matrix. So this is how you quantize. The sample brightness values are still continuous. Why? Because if you look to the image on your left hand side, you have simply you have done quantization, but still the brightness values are still continuous. Next, each element in the matrix is quantized, that is replaced by an integer value. Quantized values are called gray levels. So 8-bit image has 2 to the power b gray levels from 0 to 2 to the power b minus 1. The range of gray level is called the dynamic range of image. So you can see here, you have the spatial resolution, which is an important parameters while you are digitizing an image. How do you define the smallest element of the picture? You can see 8 centimeter per pixel on the right hand side, then you have the 4 centimeter left hand side below picture. As you improve the resolution, then you have 2 centimeter per pixel, then you have 1 centimeter per pixel. So the top image on your left hand side, which has the best resolution, is a fine image, whereas the right hand side below image, which has a very poor resolution, is a blur image. It is not well defined. So the important parameters when you digitize an analogous or a continuous tone image into a digital image is the spatial resolution. Spatial resolution, the picture at 1/8 resolution appears blocky and artifacts called pixelization. So this is what, when you do the digitization and the resolution is not appropriate, and those who have done a course on image processing, they would be knowing what do you mean by the sampling rate must be sufficiently high in order to accurately represent the original continuous tone image or scene. Otherwise, you get this pixelization artifact. You can see that there is a girl, but where is the eye of the girl? Where is the nose of the girl? You are not able to locate because the resolution, the spatial resolution is poor for this particular image. That means the smallest element size is not finely or appropriately defined. It has to be still finer, then only you will be able to see the finer details or maybe sharper image. Spatial resolution is important. Then another is the brightness resolution. These are the two important components related to the image processing when you digitize the continuous analog image into a digital image. Refer to how accurately a pixel gray level can be represented, the brightness of the corresponding point in the original scene. During quantization, the brightness sampled at each point in the continuous tone image is replaced by an integer value. I hope this picture is clear. 3 bits you are representing. If you are using 3 bits, so the resolution would be 2 to the power 3, that is 8 minus 7. So you will be having 7 different levels which are defined. As you increase the number of bits, higher would be the resolution. That means one is spatial resolution. What is the smallest element in your image? Now, when you talk of brightness resolution, what is the brightness, the different levels of the gray intensity? What are the different levels? One is the smallest element, and each element further different levels. Smallest element, that is a spatial resolution, and each element, what are the different levels? The more are the number of levels, the finer, the sharper would be the image. So these are the two important components of digital image processing. What is the spatial resolution and what is the brightness resolution? When you are transforming the analog continuous tone image into a digital image. So you have to be very particular because these two important factors will have an important further image processing steps what you are doing. Brightness resolution, you can see here. If the brightness resolution is not appropriate, say on your left hand side you have 8 bits. That means there are 256 gray levels. There are 256 gray levels. The same scene, when you are using only 4-bit, that means you have 16 gray levels. You will find that this is how the image would appear to. So this is the effect of brightness resolution. In the earlier figure, you can see here we see the effect of spatial resolution. If the spatial resolution is poor, this would be the pixelization, would be the error. And if the brightness resolution is not appropriate, you will find this wedge shape of image of a continuous varying from maximum black to maximum white. These would be the effect on the image. With this, once we have obtained a digital image, then only the question comes of image processing. Analog image captured from the camera has been converted into digital image, defining the spatial resolution and the brightness resolution. Once that has been defined, now we have a grayscale image. We would be processing them. So we'll look into the different processes of image processing. Is a data processing procedure of image using computer in order to perform a spatial task. Processing of digital image includes what operations? Digital image such as acquisition, storage, retrieval, translation, compression, etc. So these are the levels of image processing. Image acquisition, pre-processing, that is filtering, enhancement. We'll look into these low level. Then you have intermediate level, that is segmentation, region or contour extraction. You define different regions. Say like for example, mining, whether it is a marble or it is a granite or it is a sandstone, what all. So you define different regions. So that is known as segmentation. And then you are labeling also, grouping them. These you mark it with yellow, you mark it with red, you mark it with blue, and you mark it with green. So these are the different regions. So intermediate level of image processing is segmentation. Next comes the recognition. How do you recognize? The region feature analysis based on the features. Features would be maybe texture, maybe shape, maybe size, the orientation, the position. These are the various features which will define that yes, this will give the recognition of the regions. And then modeling, volume deformation module. I'll show you that how do we achieve this deformable model. Mathematical modeling will be touching upon these so that you can now identify that yes, what are the characteristics of the image which has been captured by the camera fitted in the drone. So these are the various applications, maybe a Milky Way, these are different. Yet another example, observed image of Saturn. You can see these are the images which are maybe blur or which are hazy. So image processing tools help you in improving the quality of the image. See, this is another law enforcement. Motion blurred license plate image. You cannot see what is the number. Since the vehicle is moving, your camera, and this is known as motion artifacts. These are known as motion artifacts. You are capturing, but since the vehicle is in movement, you cannot capture the number plate. But image processing tools will help you in identifying. We'll see that yes, how do we do this? Restoration of HST images. You have restored the galaxy. It is better. You can see right inside. Similarly, the same image which was blur or hazy, now it has been restored. Before repair and after repair, you can see. So how important the image processing is. Whatever you would be capturing the image using the drone, these images have to be processed and repaired. This is what you can see. Now you are in a better position to identify the different regions and segregate them to find the characteristics of the different regions. See, restoration example. On the left hand side, the number plate, it is blur. Hazy image is there since because of the motion artifacts. Using the image processing, you are able to recover the number to a great extent, 6689, whereas it is not at all visible on the image on your left hand side. So these are the various examples or the insight of the different image processing tools or image processing methods. Now let us see what are the different image processing tools. Where does blur comes from? Optical blur, camera is out of focus because you cannot focus while the drone is flying. It is not possible for you. You may have some arrangements now with the advanced camera fitted on the drone. You can even focus also, but at times while it is flying up or down, whether it is inverted or not, while you are capturing the image, it may be out of focus. So the blurring of the image may be because of the optical blur, or it may be because of the motion blur. The camera or the object is moving. Why do we need deblurring? Because otherwise it is visually annoying. You can see here. Now, you cannot see the number plate. What all it has been done. Say suppose a photographer comes with a camera, says this is the number plate. You'll be getting annoyed. What are you showing me? Nothing is visible. No, sir, this is the image I could do. The car was moving very fast. I could not see. This is what I can do from my camera. So this is visually annoying. Wrong target for compression. You cannot compress this image because it is already blur. And if you further compress and decompress, and if you do the destructive compression, then there are chances that you may further lose the characteristics or the features of the image. Bad for analysis. For numerous applications, you need to deblur the image. Modeling blurring process. What are you doing? Linear degradation model. Blurring filter, you use a filter and you additive white noise you add, and this is what you get. This is mathematical modeling, linear degradation model. What happens is to the clear image, you add white noise, and because of that, the image get blurred. So what is important while you are doing the processing? You should know the characteristics of the noise which is affecting the image. As you know that, yes, I'll give you another example, maybe not very relevant, but if when you are treating a snake bite patient, you should know that, yes, which type of snake has bitten. So accordingly, you give the counter dot. Same is the case here also. Which type of noise has affected the image? If you know the characteristics of the noise which has affected the image, then you will be in a position to improve the image in a better way. So improving the image quality is known as image enhancement. Image enhancement consists of a collection of techniques that seek to improve the visual appearance of an image or to convert the image to a form more amenable to human and machine analysis. Maybe you are using artificial intelligence for an image analysis, or maybe human analysis also. So they need to be, the quality of the image has to be enhanced. These are the various techniques. Gaussian filters can be used to appropriately out of focus and blur. This is one method which is applied. How this is being applied, I'll show you how the various filtering techniques or filtering algorithms they are being applied. I'll show you that. These are just to show you how what are the motion blurring can be approximated by 1D low pass filter along the moving direction. I'll show you. Don't have some patience. I'll show you how these, as I told you, 1D low pass filter, one-dimensional low pass filter is applied. Image enhancement method, gray level transformation. These are various methods: smoothing, sharpening. What are the image transformation? Basic gray level transformation, image negative, log transformation, power law transformation, piecewise linear transformation. These are just depicting the various. Which transformation is to be applied will depend upon what is the type of the image, what is the type of noise or the artifacts which has affected the image. So all transformation for improving the image quality will depend upon the image characteristics, the image quality, where from it has been acquired, how it has been acquired, what type of noise has affected the image quality. So histogram processing, histogram equalization, histogram matching. So this is, you can see in image smoothing, a filtering mask is moved from point to point in an image, and at each point the response is calculated using a predefined relationship. You have a filter mask on the image. This filter mask is moving. How it is moving, I'll show you that also, and you get an output image. Here you see, you have a filter mask. I represents the input image. You use a filter mask. What is the filter mask? This is how. And can anybody tell on this input image, what are these numbers representing? Can anybody tell what are these numbers representing on the left hand side input image? The participants are able to interact on audio or not, Dr. Abhishek?
Intensity, sir.
Intensity, very good. Yeah. So intensity, which is being defined as a different gray levels of the input image. Now, when you operate the filter mask, how it is operating? It is a 3x3 filter mask, which is moving on the input image. Each square of the input is depicting the smallest pixel, and the value within this square, small square, is depicting the gray level of that particular pixel. So now the filter mask is this, it is moving on the image, and while it is moving, it will be moving from left to right and then from top to bottom. So it will be continuously moving. So how it is processing? Just see here the filter mask, how you are getting on the underneath image. You can see 1/9, 10 into 1. So finally what you get is, you get an average, and that average is 3.4. So in place of 1, now you have represented the 4, which is the average. You are taking out the average. The central pixel of the filter mask is moving on the input image, and as it moves, so whatever is in the center will be getting the average value of these surrounding 9 pixels. That is what is the average filter. Has anybody question about how this average filter is operating on the image? So far I have just shown you that yes, what is the effect, but this is what is the insight of how the filter mask or any other transformation would be processing on the image bit by bit, or you can say the pixel by pixel. Each pixel is being taken care. These are the effect of different filter masks. So they will have different effect. If it is a 7x7 filter mask, the effect would be different. 3x3 mask average, this would be different. That was an average filter. You have a median filter. The pixels containing the image area encompasses by the filter are ranked, and then the value of the center pixel replaced with median value of the order set, particularly useful in the presence of impulse noise, but damage thin line and sharp corners in the image, non-linear behavior, expensive to learn. So this is how you can see the median filter, what it is doing. 3x3 median filter is moving again on the input image. And what are you doing in the median filter? All the pixel values, the gray intensity values under the filter mask, they are sorted in the ascending order of the grayscale. So the median value, which is the center value, is then assigned to the central pixel under the filter mask. How the median filter would be operating on an input image. This is just an enlarged view. The input image, what you see is an enlarged view of an image where we are showing at the smallest level at each pixel, which is the smallest element of the image, how the image processing is taking place. This is what is being depicted here. These are the various images showing the effect of the filter mask when they are being applied on the image. Image sharpening is achieved by image differentiation. What we have been doing in the smoothing, that was averaging, right? Sharpening, or you are integrating. You are integrating basically here. When you do the sharpening, you are differentiation. Image differentiation enhances edges and other discontinuities and de-emphasizes area with slow variation in gray level values. So wherever you have the edges, image sharpening, when you are using differentiation, you are identifying the edges. What is the application of identifying the edges? Because it is the edges which will demark the different regions, and you will be able to find out the different regions will have different characteristics. We'll see that how this is being done. You can see here. Now, two adjoining pixels, one is dark black and another is light black. So there is a change in the intensity. So there is a edge. As such, if you look from a distance, you may find it is all black. A big square black. But no, there are two rectangles with two different gray values. Is it visible to everyone?
Yes.
Yes. Fine. So you have an edge. And this edge is identified. Why edge identification is important? Because edge would only will be able to define the different regions. Once you define the regions, then only you will be able to identify the different regions with different characteristics. As you have seen, the application, the final, the green region, maybe yellow region, the red region, vegetation would be green, which is no vegetation, maybe brown. So this is what you have to find out, the different region. So region of interest has to be found out. This first order derivative, you are aware of. How do you find the first order derivative? You convolve the image, -1, 0, 1. This is the mathematical modeling of the derivation. I'll not be going into detail of mathematical modeling, just to give you an insight at how the ground level, the image processing is taking place. This is how robot operator, you are convolving. And this is, you can see here, since my specialization is more in medical images, so by and large the examples what I have taken here are related to the medical images. So you can see here the different regions have been identified with different gray values. The bright level has been identified. You can see here the edges have been identified, but the same process would be applicable when you take it, maybe a mining related images, or maybe a forest related or wildlife management, different regions. What is important is to identify the edges, and these are the different operators which how they are applying. I think this you should be in a position. This is convolving. Convolving means you are making this filter or the edge detector to move from left to right and top to bottom on the image, and whatever is the operation being performed at each pixel value with this convolving mask. This is known as mask. So accordingly you get the image, processed image. This is pivot operator. Again, as an edge detector, you can see from the image, once the edges have been identified, you can segregate the different regions of the image. Sobel edge detector. This is giving more weight to the 4 neighbors. You can see here, 4 neighbors, they are getting more weight. while you are convolving the image. So this is what is you are getting better image as compared to what you got in Privet. This image on the right hand side, you can see the edges are in this are better defined as compared to the earlier operator. That was first order. You have a second order. Peaks of the first derivative of the input signal corresponds to zero crossing and the second derivative of the input signal. This is second derivative is the Laplace operator. You can see mathematical modeling is double differentiation. So you apply the Laplace operator on the input image, and what you get is here you can see two-dimensional x and y. Earlier one, it was only in one-dimensional, right? When you do this second order derivative, you are doing in x and y, both the directions you are processing. So once you have identified the edges using different operators, first is filtering. Look into the initial flow diagram of the image analysis. First was capturing, second was filtering, next was, third was segmentation. So for segmentation, you have used edge operators to find the edges and then finding. So this is what is the segmentation. Refers to the decomposition of the scene into its component. Image segmentation partitions the image into disjoint non-overlapping regions. These regions correlate strongly with the objects or features of interest. Right? So these are the various techniques which are being used for segmentation. We are short of time. I'll not be going into detail of each one. Just then you defined regions and edges. Edges are found based on the differentiation between the values of the adjacent pixels. We have seen the edge operators, the first derivative and the second derivatives, which are finding the difference between the two pixels, adjoining pixels. Regions are founded based on the similarity between the values of adjacent pixels. Thresholding, another technique for identifying the regions. Classifying pixels in two categories. Properly below a threshold, you define all pixels below a particular gray level are in one region, and all pixels above a particular, so that is the level is known as thresholding. You have fixed thresholding, you have optimal thresholding. This is the effect of the different original image when you do the fixed thresholding, when you do the optimal thresholding, edge-based segmentation, region-based segmentation, the different techniques. Then comes region growing. What you do is, once you identified that these they have different gray levels or they have different characteristics, the different pixels in the image, you segregate them. Once they have been segregated, now you have identified this is a different. So you implant a seed. And what happens when the seed is being planted? It grows and it converts into a tree. Something similar happens here also. A similar approach to image segmentation is the start with some pixels. These are known as seed pixels, representing distinct image regions, and grow them until they cover the entire image. Entire image means a particular region with specific characteristics. Within these limits, you define the threshold. I take a small point on the image and see what are the characteristics of the neighboring. If they have the similar characteristics as that of my seed pixel, I say that yes, you are within this region. Then from 1, I had taken 4 neighboring. From 4, I again check the neighboring, another 4. So like this, you multiply and you grow the region. For region growing needs a rule describing the growth mechanism, a rule checking the homogeneity. Homogeneity means they have a similar characteristics of the region after each growth step. In seeded growing, we start with seed region and grow large regions, satisfying regions constraint. That means, okay, they are there within that limit. Okay, you are of my same characteristics, so we are of the same region. So this is how the seeded regions they are growing. This is known as pixel aggregation. This is seeded region growing. How do you, from the image, original image, you have defined the different regions. Region merging. When you find that two regions which are distinct apart, you can merge them because they have the characteristics of the regions which are within a specified limit. They both have the same. And what are the different characteristics? Maybe, for example, arithmetic mean, standard deviation of a class region having n pixels. So you have median, mean, you have a standard deviation. If they are same, what you do is that you merge. How that is happening? I'll show you some example. Region splitting. Within a region, if you want to have finer details, what you can do is that you can say first what you had done, all which are having the gray values from 0 to 10 will be in one group. Now you have to further improve the resolution of the, or you want to go into the finer details of the image. What you do is that you segregate, you split the region. The regions which are having the gray level from 0 to 5 and then 5 to 10. So you define two regions. This is known as region splitting. Split and merge. You split and then which are having the same, you again merge them. I'll give you an example right now. Still, you can see here. This will, you can see you have an image which have three different regions, four different regions in fact. One is the background, green is the background, then you have yellowish green, then you have black and you have red. So you have four different regions in the image, background plus three. So what you are doing, you are splitting the whole image, you are splitting, and splitting, you continue to split till we find that the neighboring, they have the homogeneity. You can see here, you are splitting. In the next, those who are having all, say like where you have the three written on the, just look into the image, left hand side down image. You will find one, all the brackets which are having the one type, say all green, that is background, or maybe all black, or where the number 4 is written. You see that image, all the region in this big square is having red, so you need not to split. Where you find that in a big square, you have different colors, maybe green and red, or maybe green and black. So that particular region is further split. So you continue splitting till you find that all the region within this square, the smallest element now identified is having homogeneous region. Till that time you continue to split and then you can merge, which are having the homogeneous. So this is how known as split and merge. The last technique is template matching. Matching can be used to locate objects of known appearance in an image to search for a specific pattern. The best match is based on some criteria or optimally, which depends on the object properties and object relations. You can see here, you have a template. What you do is that you move the template over the image and pixel by pixel, you have a template which is moving on the image. So suppose I take a pen and this is, so on this surface, so this is my image which also have an pen. So now what I'll do is from this corner, I'll move this pen image, and wherever I'll find that this image under on this my basic image picture have the pen, so you match it. The pen is matching with pen. So something similar happens here with the template matching. You can see here where the template is matching in this particular image. You say this is what is the template matching, right? So with these various operations, how the image processing is in action, because I'm not going into the coding details. Let me see if this plays, or others I'll show you how this, just let me switch over. I'll show you how this Just a minute, just a minute. Let me look into my. It's not playing. There's some problem. Just let me show you that last slide. I just want to show you why this is not working. Let me see. I think there is some problem with the.
No issue, sir. Sir, you may skip it, sir. No issue.
Just let me see. How it was interesting slide which would have been able to give you an insight about the player. I don't know why this is not getting. Okay, yes, now it is playing. I'll show you. Just let me. Share. See, now is it visible to you?
Yes, sir. Now visible. Video is visible, sir.
Yeah. Is everyone able to see that? Yes, how this algorithm is working, and you are segregating the different reasons. I'll play again. Let me see. See. So you are segregating different reasons. This is just an film. I thought that will be interesting. So to show you that yes, once the image has been captured by the drone and doing the image processing technique, how the different reasons, you can see here, where does this algorithm stops? When it reaches to the edge, and when it finds that yes, the two reasons, adjoining reasons, they are altogether different intensity. So with this, I end the presentation. If you have any question, I am already crossed the mark. 3 o'clock I was supposed to wind up, but since we started late, I had exceeded my limit. I tried to cover up the best possible slides within this small or short time. Any questions, please? Any questions, please? Or Dr. Abhishek, we should wind up. You want me to be there for the valedictory, and I'll continue. Otherwise, whatever way you feel, should I delink myself? Dr. Abhishek.
Dr. Vibhakar, this is Jagat here, the co-coordinator. I think sir is unable to connect due to some internet issues.
Yes, sir. Sir,
Yeah, sir is now.
Yeah.
Sir,
Yeah, sir.
please mail me, so I will share it to the students, sir. And
No,
I also request to, sir, please put it down your mail ID. So if any participant want to be connect with you, he can also drop a mail, if possible, sir.
Yeah, I'll put it on the chat box. Just now my mail ID. So I'll just put in.
Hello.
Yeah, yes, please.
Yes, sir. I have a doubt. Means, sir, how that image processing will be used for that agricultural land? Means
Yeah,
how
you would have seen this the last video which I had shown you.
yes.
There you would have seen the different regions have been identified, and it is stopping where you find the boundaries. So you have segregated the different regions. So the agriculture, when you look into that, yes, where you have the forestation or where you have the crops, you can identify, and then based on the characteristics of the image. Yes, please.
Yes, sir.
Yeah, am I audible to you?
Yes, sir. Audible, sir. Audible.
So you would have seen Mohapatra, is it Mr. Mohapatra who is asking the question?
Yes, yes, sir. Yes, sir. Yes, sir.
Yeah. So when you look into the agriculture, you find that there is a farm, there is a barren land, there is a farm. So there are different regions which have been segregated. So you have seen how this image processing tools, they are operating on the image and they are segregating different region in the video film I had shown you just now. I hope you
Yes,
have
sir.
seen, you were able to see that film.
Sir.
How
Yes,
this,
sir.
so they are encompassing the different regions, the boundaries in the image which has been captured. Once that regions had been identified, you segregate that region, isolate that region, and then do further analysis. Further analysis in the way that yes, if it is a texture image, what is the texture? What are the characteristics of this texture? So from that you can identify which particular crop has been grown. That can also be identified. First thing is that you the identification may be the type of leaf. So that would be all manually. You can see, look to the image and identify this is the crop. This is rice crop. This is wheat crop. You can, depending upon the leaf, because based on our experience, so that is what characteristics of the leaf they have to be given to an AI application software, and that will identify that yes, what is the type of crop. So what I mean to say is that the first thing is that you define the different regions in the image captured using the drone, the different regions, then you look into what are the different characteristics, maybe the texture, what type of texture it is, what is the shape, what is the orientation. So these are different characteristics within the regions which have been isolated. So then you identify that yes, which is, this is how you go for it. Yeah.
Yes, sir. So if I go to that or narrow down that if one fruit will be ripe or not, can it be possible through that
Yes,
using
yes,
that
yes,
UAV?
yes, yes, you can find
Suppose a
it out.
mango,
Say
yeah,
suppose
suppose a
what you
mango,
can do is, say suppose you have a mango
yes, mango or
farm,
tomato, yes,
mango farm is there. So
yes,
and you have a big farm. It is not
yes,
possible for you to go every time and find out yes whether it is ripe or not. So you can fly
yes,
the drone. It will go to and it will just take the images from different places.
yes,
And once the image has been taken, your AI activated software will find out the different regions. Means they'll find out the mango. Within from the mango tree, they'll find out the mango. Once the
yes,
mango has been found out, the region has been identified. Then what are the characteristics of that particular region?
so
Based on that
sir,
characteristics may be characteristics may be color, or it may be texture. So those characteristics would define yes whether it has ripe or not.
so within that region, how I can identify a single that mango, that whether it be ripe or it will be on ripe.
No, you would have seen the images, the initial images when I had shown you the drone application, different images you have seen. You have identified the different men moving. You have isolated different men. So similarly,
Yes,
on the tree also, when the drone is moving, you capture an image. You find. I hope Mr. Mahapatra, you would have seen the mango tree and how the mangoes they are there on the tree. Have you
yes, sir.
ever been?
Yes, sir. Yes, sir.
You see, no, so definitely the mango has a different texture or a color
Color,
from
yes,
its leaf. I have a mango tree in my house itself.
yes,
So
sir.
I know that yes, looking at a glance, you can find out yes, how many mangoes they are there, and looking, because we have developed an intelligence. So the same
Yes,
intelligence is being applied into AI tool, which is doing the image processing. And how do you find out? You say that yes, it is slightly turning yellow. From green, it is now turning yellow. And the texture is also changing,
yes, sir.
right? If you look to a, what do you call this, which is not ripe mango, it will have a thick skin. But when the mango is ripe, especially in UP belt, you find this Langda mango, which has the quality. So that have a very thin skin mango. So, and the thin will be only when the mango becomes ripe.
Right.
So the texture of the top will change. Whether it is rough or it is smooth, that texture quality also you can check up through the image processing.
Sir, last question is that with the means along with that AI and that image processing, what are the physical component we need to capture that image? Means exact image and how it will be means identify. Means what are the physical component I need with the along with the UAV?
Physical component would be maybe a good quality camera, a digital camera. You maybe have SLR which is being loaded on the drone while it is flying on the field, or maybe on a mining. The mining region also, which is a different terrain, difficult terrain, or maybe landslide. If you are having landslide, which all region where you have land, where you have water, whether the land is muddy or it is solid, will depend upon the texture. As you can see, what is all, after all, AI is what? The way when you say looking to a particular land, you can say, no, it is muddy. You can say that it is, no, it is a solid. It is with rocky land or rocky region, based on our intelligence. As we grow from a small kid to a grown-up man, we have developed the intelligence. Looking to that particular region, we can identify that, yes, whether it is a muddy region, or it is a rocky region, or it is a smooth region. So similarly, those AI tools would also be identifying based on the characteristics of that particular region.
Yes, sir. Okay. Thank you, sir.
You're welcome. Any other question? If you have any question, if you have any point, I had already shared with everyone my mail ID. If you have any query with regards to the topic what we have discussed, I don't know whether this image processing has been covered earlier or not by any of the August speakers for the FDP. I am the last speaker, and the responsibility was given to me to take up this particular topic. Yes. Yes, Mr. Jagat, anything?
Yes, sir. No, sir. I was just saying that thank you for the nice talk, and I was just going to wind up down while you were talking, sir.
Fine. So,
sir, you'll be present during the valedictory session, sir. We'll start after the assessment. So we plan to start the assessment at 4 o'clock. Once the assessment is over at 4:20, then probably we can start the valedictory sessions.
So you will be sending me the link again, or the same link would be applicable? At what time should I? Same link at what time?
Same link. So we will try to finish up the test. The test duration is from 4 to 4:20, so we can probably start at 4:25. It's the same link, sir.
Okay. So 4:25, I'll just see whether the link is active, and I'll come back again.
Yes, sir. Yes.
Right.
Thank you, sir. Yeah.
Thank you, Mr. Jagat. Thank you,
sir. Yeah.
Thank you, sir. Thank you very much, sir. Thank you, sir.
Thank you, Dr. Abhishek. Thank you.
So participants, please note that the last session for the feedback and valedictory starts at 4 o'clock. So we will wait till 4:05 for all the participants to arrive, and then we'll start the test. The test, as I mentioned, is of 50 multiple choice questions, and it will be of 20 minutes duration. So you'll be doing it through Google Forms. So we'll send the link at 4:05 and you can start the test. Once the test is over, we'll start the valedictory session. So everybody is please requested to be on time for the last session. Thank you.